Hey guys, this is Mr. Sal. We're going to look at simplifying square roots specifically. We're going to use three methods, one of which is calculators. So thanks for watching. If this helps you out, please subscribe to the channel, like the video, and make a comment below. Alright, turn the page. We should be on the second objective then for this part of the lesson is that I can simplify roots with a calculator. In this section, we will learn two strategies for simplifying square roots of numbers. That's not true. It's going to be three that are not perfect squares. Both strategies are really doing the same thing, but the methods for each are a little different. Think back to one of the previous lessons. What does it mean to simplify a square root of a non-perfect square? What was the difference between the simplified version of these square roots as opposed to how they looked before they were simplified? So we can get some answers like this. Don't worry about it for now. When we were simplifying before, we were either dividing the length of a segment or the area of a square into as many segments or squares as we could that would give us the smallest non-perfect square possible. Simplified versions always contained a number in front of the square root, which we will see. So perfect squares, we did cover this in Unit 2, but we're going to go over it again. So the perfect squares, some of the perfect squares that we've gone over, just the first 12 would be like 1, not 2, 4. Yeah, we've seen 2 already, right? 4, 9, 16, 25, 36, 49. I'll explain how we get these here in a moment. 49, then 64, 81, 100, 121, and then 144. So perfect squares are when we take the first 12 numbers and square them, such as 1 squared. Or 2 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. Alright, so these are the first 12 perfect squares. And in Unit 2 we expect you guys to memorize these, so hopefully this isn't like something brand new. But in relation to these perfect squares, the red numbers here, these perfect squares, if we do something to these, we can kind of go backwards in these values. That's where we want you to have it. Alright, so if I took these squares and square rooted them, then I get whole values instead of decimals that look like garbage. So in other words, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, and square root of 144 is 12. Now we're going to be using more of these purple values here in today's lesson. Alright, because if we can identify these perfect squares, then simplifying the square roots of other values can become pretty easy. Alright, so problems like this one. So this is showing the simplified form of the square root. Let's look at a couple of these, and I'm going to show you guys the first method. So the first method is where we take, for example, the square root of 8, and we're going to split 8 up into its factors. Alright? So we're going to need that perfect square business with the 8, and again, this was the first method. So the square root of 8, I just need 2 factors, but I need one of them to be a perfect square. So that would be 4 and 2. Now what this means is it's still the square root of 4 and 2, but they're multiplied together. And I can split these up so that I got the square root of 4 times the square root of 2. And we know the square root of 4 is 2. So the answer is 2 times the square root of 2, which is the answer that they have up here. So that's pretty much what we kind of do for all of these, is we look for any factor of any of these values, these square roots, that are already a perfect square. So let's try the square root of 32 as well. 32, if I split it up, I could say that you do 8 and 4, right? And 4 is a perfect square. However, if I did 4 and 8 on this, so let's split this up, so it's the square root of 4 times the square root of 8. And the square root of 4 we know is 2 times the square root of 8. Now we should check this, because 8 is not prime, it's a composite number, which means we can split 8 up even further into another perfect square, which would be the same one, 4. So I've still got that 2, but the square root of 4 is also 2. And the square root of 2 is still the square root of 2. This is multiplied. 2 times 2 is 4. And then we have that multiplied by the square root of 2, which is the answer that they had up here. So sometimes if you don't find the greatest perfect square that's a factor, then you may have to continue the pattern. If we did the greatest one with the square root of 32, then we would have split this up between 16 and 2. The square root of 16 and the square root of 2, square root of 16 is 4, and the square root of 2 is 2. So we could have gotten that maybe a little bit faster, but we have to identify that 16 would have been another perfect square factor of 32. What observations can you make about simplified versions of these square roots? Non-perfect squares, list them here. So they always include a number in front of the square root. The numbers inside the radical sign are non-perfect squares. The numbers inside the radical are all smaller than the original number. The number inside the radical is a factor of the original number. And then we can have other observations too. Alright, so we got 2 strategies. Actually, we'll show you a third one as well. So this first strategy is just saying look at factor pairs for the number inside the radical and then see if you can find any factors that are perfect squares. The biggest one would be the most convenient, but we may have to continue this pattern until we've taken all the perfect squares out of the radical. So this would be an example of it. Like the square root of 40 right there. What they're saying is that we've taken 40, we've split it up between 4 and 10. So the square root of 4 is 2, and the square root of 10, 10 is not a perfect square, so it just remains there. That's why we get that answer. Same with the square root of 45. 45 would split up into 9 and 5. Now again, we're using 9 because it's a perfect square. The square root of 9 is 3. The square root of 5 is not a perfect square, so it stays a square root. That would be the answer for the square root of 45. The second method is using a full factor tree to find all the prime factors for a number, but we have to pair these up in order to take them out of the square root. Most people don't like this method, but we'll still show it to you anyways. So this would be an example of it, where we've taken the square root of 8 and we've found the 3 prime factors of it, which is 2's. So we can see from this step right here that the 2 2's, these 2 2's, would make a perfect square because it's a pair of 2's. And that comes out as one single 2 right here. So it's 2 times the square root of 2. Same with the square root of 40. If we look at all the prime factors, 2, 2, 5, and 2, there's a pair of 2's right there, which comes out as 2. The 5 and 2 have nothing to pair with, so they multiply together to give us the square root of 10. So let's try these. 50, I will do the prime factorization, and then I will never do it again. Okay. So the square root of 50, I would split this up, I would say 5 and 10. And 5 is a prime. 10 also splits up into 5 and 2, which are both prime also. So the square root of 50 is really the square root of 5 times 2. But since we have a pair of 5's, it comes out of the square root as just a 5. And then the 2 has nothing to pair with, so this would be 5 times the square root of 2. The square root of 200, what I want to do is split this up between 2 factors, one of which is a perfect square. I'm going to split it up between 100 and 2. So this would be the square root of 100 times the square root of 2, and the square root of 100 is 10. And then we still have that square root of 2. So that would be the answer for this one. I'm going to use the same method for the square root of 72. If I can split this up between 2 factors, where one of the factors is a perfect square, like 36 and 2, well, the square root of 36 is 6, and then the square root of 2 would remain in the square root because it's not a perfect square. So that would be the answer for that one. Alright, now these ones are not on the worksheet, but I want you guys to write them down and try them. Try the top three first using either of the methods, and then we'll go over those three. Then we'll show you the third method. Alright, the square root of 1/4. What I'm going to do is split this up with the numerator and denominator. So it's really the square root of 1 divided by the square root of 4. Both of which are perfect squares. Square root of 1 is 1. Square root of 4 is 2. 1/2. The square root of 147, I'm going to split this up. It looks like it's between, well, actually that'd be 49 and 3. So that's the square root of both. Square root of 49 is 7, and the square root of 3 is just the square root of 3. So there's that answer. The square root of 36 is a perfect square. That's 6. Just don't forget to include the negative in front of it. Alright, it is now time for the third method, which has an extraordinarily fancy name. It is called the calculator method.
Wow.
So the calculator method, I'm going to show you guys how to do it with these calculators. The first button you're going to push is the top button, the top left button. Second, you'll push this button. After you push this button, you'll push the x squared button. And then on the calculator screen, it will show you the square root symbol. For this specific problem, after that, I would type in 4 divided by 25. And then I would push equals. The problem with that is that it's going to give me the decimal value. So I'm going to push the double arrow button. And then it will change the answer into a fraction, which is 2/5. Of all three methods, I prefer this one, because all I must do is type it in. I don't have to memorize any perfect squares, no nothing, just type it in. In fact, the next one, the square root of 128, if I were to type that in, so this one, again, it gave us the answer, which is what we wanted. 8 times the square root of 2. Bam. Didn't have to think about it, just had to push some buttons. I mean, if you got arthritis, that can be pretty tough in your thumb knuckles. But the rest, okay, sorry. Alright, the negative square root of 8 on the calculator should give you negative 2 times the square root of 2. The square root of 49 over 36 would give you 7/6. 10 times the square root of 96. So yeah, just plugging that into the calculator, we should get 40 times the square root of 6. And then negative 5 times the square root of 45. This one's not too bad. So this is the answer for that last one. Again, we're just plugging these into the calculator. It gives us the answer. That's all we want. Okay. So when you guys see this on the test, that's all we want you to do is just plug it into the calculator. Just like the objective said. We can simplify roots specifically with a calculator. That was the third method, all right? So by now, hopefully after this lesson, you guys are able to do that now and feel comfortable doing it for the test. So thanks for watching this video, you guys. I hope it really helped you out with simplifying those square roots with a calculator. If it did help you out, please subscribe to the channel and like the video and make a comment below. We'll see you guys in the next one.